you have them because you have a test on Monday. So in case you haven't been paying attention, you have a test on Monday. So we're going to go over this. And again, as I'm going over it, if you have questions, please ask those. So the first question in the CFU yesterday, and again, your numbers were different than mine, so I'm just working out my version that I have on the screen. And again, if you have questions about it as I'm going, let me know. But it looks like almost everybody got this one right. 96% of you got this question correct. It says, a car accelerates from rest at a rate of 2 meters per second squared for 10 seconds. What is its final velocity after 10 seconds? And so if I take a look at this particular question, again, as always, I'm going to start by labeling the information that I know. I know the acceleration is 2 meters per second squared. I know that this occurs for a time of 10 seconds, and I know that it starts from rest. So although it doesn't have another number in there, again, if you see the words from rest, if you see the words comes to a stop, those are telling you things about the velocity. And since it says it accelerates from rest, that's my initial velocity is 0. And so I know those things from the question. And I'm being asked to solve for the other two things that I don't know, the final velocity and the distance. So we'll start with final velocity first because it's listed first. And if I take a look at what I have labeled here, I have acceleration, time, initial velocity, and I'm looking for final velocity. We have our 4 equations up on the board, and you're going to take a look at which one to use based on the information you have and what you're trying to solve for. In this particular case, I'm going to use this equation. Final velocity equals initial velocity plus acceleration times time. That's the first equation listed on my board. Okay, and I'm using that because it allows me to solve for what I'm looking for, and it has the variables that I know, and it doesn't have anything I don't know in it, so I can use this. When I substitute in, I have VF equals 0 plus 2 times 10. Okay, which means that my final velocity will equal 20 meters per second. Okay, so that's what you should be typing in for your final velocity here, 20 meters per second. The second question says, how far has the car traveled in 10 seconds? So we're going to solve for the displacement, delta x. Okay, and if I want to solve for my displacement, again, now I have all of these other variables because I just found this one. So I have 3 different options that I can use in terms of my equations. I'm going to go ahead and use this one, but again, you don't have to use this equation. Delta x equals VIT plus 1/2 AT squared is what I'm going to use, but you could also use that last one or even the second one, although that would be my last choice because it requires more math. Because you'd have to rearrange the equation. So with this one, I'm going to say delta x equals, my initial velocity again is 0 times 10, but again, that's going to go away. 0 times anything is 0, plus 1/2, my acceleration is 2, and my time is 10, and I have to square that. And so I end up with delta x equals, half of 2 is 1, 10 squared is 100, so I end up with my delta x is 100 meters. Okay, so again, this is the process you guys went through yesterday. You submit it, should say, yep, you're all good, you have all your points. Again, your numbers are different, but that's the same process. Just real quick, if the question had said, like if I gave you the first one, a car accelerates from rest at a rate of 2 meters per second squared for 10 seconds. What is its final velocity after 10 seconds? If I had given you that and I said, what if it does this for half the time? Okay, what would the final velocity be then? Okay, because we have those types of proportional reasoning questions throughout our assignments. There wasn't one in here, but you're going to have something like that on your test. So I want to make sure that we can answer that as well. If we accelerate for half the time, and you can see this mathematically, if this was half as much, so 5 instead, what would that have done to my final velocity? Yeah, you can say it louder, Emily, that's right. It's half. Okay, it would be half as much. Your time and your final velocity are directly proportional to one another. So if you had half the amount of time to accelerate, you would end up with half the final velocity. So again, be able to answer questions like that as well, although it wasn't asked in this particular case. All right, let's take a look at the next one. We have a velocity time graph, and we're being asked to solve for 4 different things from this graph. Okay, the first of which is, what is the initial velocity? Well, that's super easy. If you have a velocity time graph, you can see the velocities because they're on your y-axis. My initial velocity is 4. That's all I have to do is read the y-axis, 4 meters per second. Final velocity, same thing. I can see it. It's right here. If this is 4 and this is 5, then this line in between would be 4.5. 4.5 meters per second. Acceleration is the rate of change in velocity. By definition, acceleration equals change in velocity over time. And if I look at my graph, my change in velocity is my change in my y value over change in x. That is rise over run. Again, if you need to write it down, but the slope of your VT graph is acceleration. So if I want to find acceleration and I'm looking at a velocity time graph, I am going to find slope. Okay, so rise over run, I only go up by a half the whole time. So half over the total time was 8 seconds, so that would be 0.5 divided by 8. And that would give me a pretty small number. Let's see, 0.5 divided by 8 is 0.0625. And so that would be my acceleration, 0.0625. And again, my units, meters per second per second. Okay, if you can probably type meters per second, caret 2 to put the squared down there, but I'm just going to type it this way if it doesn't allow me to make it a superscript. Okay, last question is, what is the displacement? Again, displacement on a velocity time graph will be your area under the curve. Again, it's not a curve on our graph, it's a line, but it's the area underneath this blue line. And when I say underneath it, I mean between this and the x-axis. And so we don't have a regular shape. We have like a rectangle with this skinny triangle on top is what we have. Okay, and so if I solve for this rectangle, 8 seconds, 4 meters per second for 8 seconds. Again, length times width would be 4 times 8. Okay, would give me 32. And then I have this tiny little triangle on top because at 4, it obviously goes up from there. The base of this triangle would be 8. So triangle 1/2 base times height. The height, though, is only 0.5. Okay, so half of 8 times 0.5, half of 8 is 4 times half again would be 2. And then I have to add these together because I want the total area. So that's the area of the rectangle, that's the area of the triangle. The total would be 34. And so that would be my total displacement, 34 meters. Again, once you have them, you submit them, and hopefully you have full credit on yours or did yesterday. But if not, that is the process. Does anybody have a question about how to get anything information-wise from a VT graph? Not right now? Okay. Let's see. Y'all got 93% of you guys got this question right. And y'all seen this question before. It was on a different homework assignment. So that's a good thing. All right, let's go ahead and take a look at number 3. Number 3, 83% of you guys got right. So it was a little trickier for some of you, and it may have been the way that it's worded. So let's take a look at it. I'm just going to turn the page to be easier. It says, an engineer is designing the runway for an airport. The planes that use the airport will start from rest and accelerate at a rate of at least 3.4 meters per second squared. Okay, so they've already given me a couple pieces of information. They told me that they're going to start from rest. That means my initial velocity is going to be 0. They also told me that they have to accelerate at a rate of at least 3.4 meters per second squared. Okay, the takeoff speed for the plane will be 76 meters per second. Assuming this minimum acceleration, what is the minimum length of the runway? Okay, so we're talking about the plane going along the ground, and it has to reach, you know, a certain speed before it can actually take off. So that's going to be my final velocity. My velocity at takeoff will be 76 meters per second. So I have VI, I have A, I have VF. I'm looking for delta X. And again, I'm going to take a look at my equations that are listed on my board. Okay, VF equals VI plus A times T. That's that first equation. I do have 3 of those things. I could use it to solve for time and then find delta X if you want. However, the second equation up there, VF squared plus VI squared, sorry, not F plus, VF squared equals VI squared plus 2 times A times delta X will allow me to actually solve for this in a single step. So that's what I'm going to do. But if you solved for time first, there's nothing wrong with that. It just means you're doing the problem in 2 steps. Rather than doing that, I'm going to use this. VF squared equals VI squared plus 2 times A times delta X. If we use this equation, that ends up being 76 squared equals 0 squared plus 2 times 3.4 times delta X, and that's what I'm trying to solve for. Okay, so 76 squared is 5,776 equals 0 squared, of course, is 0, and I'm adding it so I can get rid of that. 2 times 3.4 is 6.8 times delta X. Okay, so from here, again, if I want to get this by itself, it's currently being multiplied. I need to divide both sides by 6.8. So I'm going to take my answer in the calculator and divide it by 6.8, and I'm going to get 849.41 if I'm rounding it, so 849.41. You should have 2 decimals on all your answers on My Open Math unless it tells you otherwise, and that's going to be in meters. Any questions about that one? Again, that one about 17% of you missed, so again, if you have a question, please let me know. All right, number 4, nobody missed. Awesome. Everybody got this right. It says a car is initially traveling at 36.5 meters per second. It accelerates at a rate of negative 2.7 meters per second squared for 7 seconds. What is its final velocity? Again, you can approach this the same way. We have an initial velocity, VI equals 36.5. We have an acceleration, A is negative 2.7. We have a time, and we're looking for final velocity. And so again, if I take a look at what I've labeled here, I'm going to be using the first equation on my board, VF equals VI plus A times T, because that's where all these variables are, right there. And so if I do that, I don't have to do any rearranging. I'm just going to get to add everything together, which is probably why nobody missed this. You don't have to do a whole lot. 36.5 plus negative 2.7 times 7. Okay, so now it's just order of operations in algebra. So 7 times negative 2.7 is negative 18.9 for this, and then I need to add that to it, 36.5, and I get 17.6. So that will be my final velocity, 17.6. My unit will be meters per second. Does anybody have a question about this one? No? Okay. Number 5, if a car moves with a constant speed, does it necessarily also move with constant velocity? 85% of you guys got this right, so there were a couple people that missed it. Okay, and the answer to this question is no. Okay, if it moves at a constant speed, remember guys, we talked about this last unit as well. Speed is scalar, velocity is a vector. It is possible to move at a constant speed and to turn. We talked about that at the beginning of the unit, remember? Acceleration is speeding up, slowing down, or changing direction. Okay, you're going to see that again, by the way. And so if I'm talking about this here, I can move at a constant speed and turn. Okay, and that would not be a constant velocity. It would also constitute acceleration. But if I look at my choices, I'm going to say no, because the direction of velocity can change with constant speed, and that is absolutely true. I can take a turn at a constant speed and yet still have a changing velocity and thus still be accelerating. Okay, so that one you should have said no, because direction of velocity can change with constant speed. Questions? Kind of a definition thing, so just record that to your memory. All right, number 6, graphs. I know it's your favorite. I know you'll love the graphs. Okay, we have a velocity time graph here. On your test tomorrow and on this question, I would expect you to be able to tell me exactly what each portion of this graph means. Okay? Which way is it going, and is it speeding up or slowing down? I would expect you to be able to tell me those two things about every single, if I picked any point on this graph. Okay, so make sure that you can do that. Although here I'm just matching it, although I need to understand what it's doing in order to match it. So for the first portion of this graph, I start out with some positive velocity. There's no numbers. Maybe it's positive 5. I don't know. But I start out with a positive velocity, which means I'm going forward. And that velocity goes down until it reaches 0 right here, which means at this point, I have stopped. Now, I don't stay stopped. I actually turn around and go the other way. Okay, but in the first portion of my graph, I'm going forward, slowing down, stopping, and then turning around and speeding up backwards. Okay, that's what this shows, because as soon as I cross this x-axis, I have changed directions. On a velocity time graph, if you cross the x-axis, you have changed direction, because the top part of it's forward and the bottom part of it is backwards. Okay, so I have changed directions right here, sped up, and then I have this horizontal line, and a horizontal line on a VT graph means constant velocity. And so I have some constant backward velocity, and then it goes back to 0, which means it slows down. Again, stops for an instant and then turns around and speeds up in the forward direction. So looking at my XT graph, I need to show something that starts out moving forward and slows down. Let's just look at the first part of it. Okay, just this part right here. Starts out moving forward and slows down. I know right off the bat it's not this one, because that doesn't go forward at the beginning, because on an XT graph, forward means positive slope. Again, if you need to write that down, write it down. On an XT graph, forward means positive slope. So it can't be the first one that I have here. So let me go look at the second one. All of the rest of these are going forward. So far, so good. Okay, so they're all going forward. It doesn't matter where they are in terms of their y-intercept here. Doesn't matter. They're still going forward because it's a positive slope. Okay, and so I need to go forward, and then I need to turn around and start to go the other way, which means my slope needs to go from positive to negative. These don't do that. These two right here, they flatten out, but they never go backwards. The slope never turns negative, which means it has to be this one. That's the only one left. It goes forward, slows down, stops somewhere up here, and then goes the other direction, and then changes direction again at the end. But that one has to be my answer because of this right here. It's the only one that shows it actually going backwards. Okay, does anybody have a question about the XT graph? Yes, let me just make sure you can see it. Sorry, it's this one. Questions? Okay, guys, y'all have a test on Monday, so if you have them, please ask them so that you don't miss it. Garrett, you got any questions? Okay. Question number 7, still the same VT graph. Now we're trying to match it to acceleration. Again, I've said this already today in this review, but the slope on the VT graph is your acceleration. So if I look at my slope at the beginning, this is negative. So the first part of my acceleration will be negative. Is this slope changing? No, it's a straight line. Okay, so I need a constant negative acceleration, and then my slope is 0. So it's going to negative and then 0 and then positive. That's what I'm looking for. That's this, negative, 0, positive. It's the last one on mine, but may not have been the last one on yours. This is the AT graph that matches the VT graph up there because I have negative acceleration, no acceleration, positive acceleration, and again, that matches the slopes that I see on the different segments of my graph. So that's how you determine your acceleration. It's super easy to find your acceleration from a VT graph. That's all you have to do. Look at the slope. Is it positive, negative, or 0? Questions about that one? Man, I guess everybody's going to get 100 tomorrow. You'll have no questions. Okay. Number 8. This is probably one y'all missed. It is. 70% of you got this one right. So about 30% of you missed it. So listen up because that's a good number of you. It says, consider the position versus time graph shown below with 8 points on the curve marked. Read the statements about some of the marked points below and choose the most correct answer. And so if you look at this, let me zoom in a little bit so you can see it a little bit better. Okay, if you look at this, this is a position time graph. So I have constant forward motion because I've got a straight line with a positive slope. And then the object slows down, stops briefly here, and then turns around and speeds up in the backward direction. Then it's constant here because it's straight. Then it slows down, stops for a brief second, and then speeds up before going constant velocity forward again. Okay, so you should be able to go through that process and tell me it's going forward and speeding up, or it's going backward and slowing down, or whatever it may be doing. You should be able to look at that and tell me, okay? So looking at this, it says, the first option says acceleration is 0 at points 3 and 6. And no, it's not. This is still on the curve. And so I know that I don't have 0 acceleration. The only places I have 0 acceleration, like point 1, that would be 0 acceleration. That's a straight line. Okay, point 8, that would be 0 acceleration. That's a straight line. But points 3 and 6 are on the curve. And if there's a curve, there's acceleration. There's a change in slope. Okay, that means there's a change in velocity. So the second one says the object slows down from point 4 to 5. Again, that's definitely not slowing down. There is a straight line in between here. So that's just constant velocity backwards. Okay, don't mix this up with a VT graph. If it was a VT graph, then yes, you'd be slowing down as you approach the x-axis, but not on an XT graph. That just means you're going backwards. Okay, the next one says velocity is 0 at points 3 and 6, and that is your answer because as I mentioned, it slows down, has to stop before it turns around. And so at that point in the middle of that curve before it changes direction, it does stop for a moment, okay, at the top or bottom of the curve, whichever one you're looking at. That's my answer, but let's go ahead and talk about this one. Acceleration is positive at points 1 and 8. My slope is positive, but it's a straight line. Okay, and so that's just, if it had said velocity is positive, then yes. Okay, but not acceleration here. My acceleration is actually 0 because those are on straight lines. Okay, so your answer here is velocity is 0 at points 3 and 6. Does anybody still have a question about this problem? No? Okay. All right, let's look at the next one. This question says, suppose a group of physics students are conducting motion experiments in the gym at Bridgeland High School. They have arranged a coordinate system by extending a long tape measure along a straight line on the floor and are reviewing real-time data after measuring themselves walking along their coordinate axis. If Mark's data consists of a positive velocity and positive acceleration, which of the following correctly describes their motion? Guys, if you have a positive velocity and positive acceleration, okay, if they have the same sign, if they're both positive, or if they're both negative, by the way, if you have the same sign, that means your acceleration and your velocity are working together. It's going to make you speed up. Okay, if they're both positive, you're going to speed up going forward. If they're both negative, you're going to speed up going backwards. If your signs are opposite, positive velocity, negative acceleration, or negative velocity, positive acceleration, if they're opposite, you will slow down. Okay, so keep that in mind. So it says positive velocity, positive acceleration. That means he's moving in the positive direction. Velocity is your direction. It's positive. And because his acceleration is the same sign, they're both positive, he will be speeding up. So moving in the positive direction and speeding up is the answer that I need to select here. Again, if you need to make a note, please do it. If your velocity and acceleration have the same sign, if they're both positive, you speed up. Or if they're both negative, you speed up. Okay? If their signs are opposite, you will slow down. Okay, so this is moving in the positive direction, speeding up. Any questions about that? All right. Number 10. A car is traveling down the road at 15 meters per second. A deer suddenly jumps onto the road. The driver immediately hits the brakes, coming to a stop in 3 seconds. Draw a single line representing the velocity of the car for the time described. It needs to be exact. There's a video. All right, so 15 meters per second in 3 seconds. This is a velocity time graph. I know I start with the velocity, and I didn't put that in the exact right spot, but I'll move it in a second. I know I start at 15, and I know it takes me 3 seconds to stop. So I know that I end down there. And I'm going to zoom in a little bit so I can move these points, because they have to be exact, otherwise it counts it wrong on this one. I can't zoom back out. Hold on. Not what I need to do. There, okay. I accidentally hit forward. Okay. This one's a little bit annoying because I have it just below 15. I need it on it. There we go. Okay. Now I'm good. All right, so that's my graph. I start at 15. I end at 0. It takes me 3 seconds. Again, on a VT graph, as you approach 0, that is slowing down. If you reach the x-axis, you have stopped. Okay, that's what I have just shown you. All right, down here it says, recall that displacement is the area of a velocity time graph. How far does the car travel while braking? Could I solve this, with the numbers? Yes, you could do this with kinematic equations, but it's even telling you, hey, find the area of this triangle. So let's go ahead and do what it is asking us to do and find area. Okay, so I have a triangle there, and again, the area under the curve will be my displacement. This is a VT graph. And so that area is going to be 1/2 base times height, 1/2 3 times 15. Okay, and again, you can just put that in your calculator, but half of 3 is 1.5, so 1.5 times 15, and that gives me 22.5. And of course, this will be in meters. Now, could you have gone up there and said, okay, VI is 15, VF is 0, the time is 3, and solved? Yes, you could have, and that would also work. Okay, but it'll get you the same answer, and finding the area is probably a bit quicker, 22.5 meters. Does anybody have a question about this particular problem? Okay. Let's see, how'd y'all do on that one, number 10? 91% of you got it right, so it looks like y'all did pretty good. Number 11 was one of the ones that was more missed. Only 70% of you guys got this one right. It says, a maglev train accelerates at a rate of 0.98 meters per second every second. Accelerating from rest, it can reach its top speed in about 86 seconds. What is its top speed? Okay, so let's go ahead and take a look at this problem. I've got some information given to me in the question. I know the acceleration, okay, is 0.98 meters per second squared. I know that if it accelerates from rest, so they've put that in there, my initial velocity is going to be 0. And the time is going to be 86 seconds. So I know from that information how to find final velocity. Okay, and again, that equation with this information will be VF equals VI plus A times T. Plugging in, that is VF equals 0 plus 0.98 times 86. Okay, again, don't worry about the 0. We're just going to multiply 0.98 times 86, and that's going to give us 84.28, and that will be our final velocity, 84.28 meters per second. how far in kilometers has the train traveled after 86 seconds? So now we're looking for delta x. Let me go ahead and fill this in. 84.28. Okay, so now we're looking for delta x. And again, I have multiple ways I can solve for this because I have every other piece of information. But I'm going to go ahead and use this one. Delta x equals VIT plus 1/2 AT squared. Substituting into that equation, I have 0 times t. That's just going to go away because it's times 0. Okay, 1/2. A is again 0.98, and my time is 86, and we have to square that. Okay, so that's going to be a big number. 86 squared divided by 2, because that's times 1/2, and then times 0.98 gives me this. Delta x equals 3,624.04 meters. This is in meters. This wants kilometers. So you do have to do a conversion before you put your answer in. Okay, there are, and you should already know this by now, but there are 1,000 meters in 1 kilometer. And so if I want to convert meters to kilometers, I just need to multiply by that conversion factor. 1 kilometer is 1,000 meters. Again, that allows me to cancel that unit, but I'm really just dividing by 1,000. So I'm going to take that answer and divide by 1,000, or you can just move your decimal because you should be able to see that. And you get this, 3.62 kilometers. Does anybody have a question about number 11? Make sure you don't mess up with those unit conversions if we give them to you. All right, number 12. Number 12, 94% of you guys got right. It says, assuming minimal air friction, how fast will an object falling from rest be going after 5 seconds? Okay, again, this is a free fall problem. I know if I have an object falling from rest and there's minimal air friction, meaning there's basically no air resistance, then I know that when I have anything in free fall, my acceleration will be due to that gravitational field on Earth, and it will give me an acceleration of negative 9.8 meters per second squared. Okay, it wants to know how fast it's going to be going if it is dropped from rest. So my initial velocity is 0, and my time after 5 seconds is what it's asking. So my time is 5 seconds, and I'm looking for how fast it's going at the end of this. So I'm looking for final velocity. Okay, now the question says speed. Okay, the only difference is when I solve for my final velocity, it's falling, I'm going to get a negative number. But I'm not going to type the negative number in here because it wants a speed, not a velocity. It just wants the number answer, the magnitude. We're still going to solve it the same way though. Same equation we've used a handful of times. VF equals VI plus A times T. So VI is 0. A is negative 9.8, time is 5. So it's just negative 9.8 times 5. I'm going to just drop the negative because I already know I'm not going to need it. You're going to get negative 49 with this, but again, because it's asking for speed, I don't want to put the negative in my answer anyway. So 49 meters per second would be how fast it's going. The direction it's going is down. That's what the negative sign means, is down. But it doesn't want that here. And it even says, give only the magnitude, no negative. So it gave you a hint as well. How far will it have fallen? Okay, that means that we need to find delta x. How far? Again, when we solve for it, we're going to get a negative number because it's falling downward, but it's asking for distance here. So we're going to ignore the negative when we enter it. But we're still going to solve it the same way. Again, delta x equals VIT plus 1/2 AT squared. That's the equation I'm going to use. VI is 0, so VIT is going to be 0 plus 1/2 times negative 9.8 times t squared. So again, I can ignore the 0. Half of negative 9.8 is negative 4.9 times 5 squared is 25. And I get negative 122.5. But again, that's my displacement. I don't care about the sign when I'm asked for distance. I just give the magnitude, 122.5 meters. Does anybody have a question about number 12? Okay. Number 13. This was one that was more missed. 75% of you got this right. It says 2 balls are dropped from the same height 1 second apart as shown. Choose the most correct statement below. The statements say the distance between the balls gets larger and larger. The distance between the balls gets smaller and smaller until the second one overtakes the first one, and then the distance gets bigger and bigger. The distance between the balls gets smaller and smaller until the second one catches up with the first one and then they fall together, or the distance between the balls stays the same. Those are your options. Okay, you can actually use the graph to help you see this. Okay, but what's going to happen here is the distance between the balls is going to get larger and larger. Okay, although they have the same acceleration, the fact that one of them was dropped a second earlier means it's going that much faster each second compared to the first one. And if it's going that much faster, it's also going that much farther each second. But you can also find the area of the triangles. For example, after 1 second, let me get a fresh sheet to write on. After 1 second, and I'm just going to write red and blue because that's what you can see on the graph, red, blue. Okay, the red one after 1 second will have traveled, and again, you can use 1/2 base times height, so, because this is a triangle. 1/2 of 1 is half times -10, so half of -10 is -5, whereas this one's at 0. So the difference here between the two is -5. After, and this is at 0 seconds, or I guess it's after 1 second, sorry. After 1 second. After 2 seconds, okay, again, if you look at the triangles, now I have a bigger red triangle. 1/2 base times height. Half of 2 is 1 times -20. This is now at -20. This one, on the other hand, is at -5. Again, my difference between the two here is now 15. Okay, so difference was 5, difference is 15. If I keep doing it, my next one's going to be 25. They're going to get farther and farther apart. If you solve for the areas, you can see that. That's why I put the graph in there to hopefully help you see that if you didn't already know this. But the distance between them gets larger and larger. Okay, so that's the answer to that one. Does anybody still have a question about number 13? Okay. Number 14 is another calculation. This time it's for a ball thrown upward. So we're still dealing with free fall, but now we have an initial velocity upward. It says a ball is thrown straight upward with a speed of 12 meters per second. So I have an initial velocity of 12 meters per second. And that's all it tells me. What is the velocity of the ball at the top of its path? Okay, well, I actually don't have to do a calculation for this. Guys, what's the velocity going to be at the top of the path? 0. Okay, because that's the point where it has to stop moving up before it starts moving down. So this looks like a calculation, but it's not. Let's read the second one. What is the acceleration of the ball at the top of its path? Well, I don't have to calculate that either. What is my acceleration?
0.
-9.8 at every single point. It doesn't matter if it's at the top or if I just threw it or if it's halfway up or halfway down. It doesn't matter. The acceleration is the same at every single point. It's -9.8. It's gravity, meters per second per second. Okay, this looks like math. It's not. It's not. You don't have to do any math to answer that. Okay, you need to know that though. Make sure you know that. You need that for math if you do have to do it. But and you may be asked a question just like this on your test. I can't remember, but it wouldn't surprise me if we have something very similar. Yes?
So even if it's going up, it's still -9?
Yes. Yeah. Even if it's going up, it's still -9.8. In fact, if it wasn't negative, like if it's going up, let's say, I'm going to use 10 instead of 9.8 just to make it easier. Let's say you throw something upward at 30 meters per second. If your acceleration when you were going up was positive, that means it would get faster. Plus 40, plus 50, it would never slow down and stop. Yep. Your acceleration has to be negative because it has to slow down, stop, and then turn around. We know what happens. Okay, so it goes from positive 30 to positive 20 to positive 10 to 0.
Gotcha.
And then it speeds up when it falls back down.
That makes sense.
Okay, that's a good question though, but any other questions? Chris?
So anything that has to do with like gravity or free falling is always going to be -9.8?
Yes, your acceleration for anything having to do with free fall will always be -9.8 even if the object's going up. even if it's at the top and it's not moving. Okay, it doesn't matter where it is. At every single point, it's negative 9.8. Other questions? Okay. All right, last one in the quiz says, a rock is thrown straight upwards from level ground with an initial velocity of 24 meters per second. How high does it go? Same idea as this picture. I'm going to redraw one. Okay, 24. Okay, so it's going to go up. It's going to come back down. Again, if I want to solve for how high it goes, I'm looking for this. And if I need to find that displacement, then I need to know something about that point. What do I know about that point? Sorry? The velocity right here is 0. I know that about that point. Okay, you need that to solve this. You can't solve it without it. Okay, so I have an initial velocity of 24. I have a velocity at the top, which I'm going to go ahead and call the final. I know it's not the end of the trajectory, but it doesn't matter. That's the final point for my calculation. And I'm going to solve for the delta x at that point. The other thing I know is acceleration is negative 9.8 meters per second squared. So I have VI, I have VF, I have A. I can find delta x. The equation I'm going to use is the second one on my board. VF squared equals VI squared plus 2 times A times delta x. Okay, plugging in, that is 0, squared is 0, plus equals 24 squared plus 2 times negative 9.8 times delta x. Okay, so let's get 24 squared. 576. I'm going to subtract that from both sides. And I have negative 576 equals 2 times negative 9.8 is negative 19.6 times delta x. And now I just need to divide both sides by negative 19.6. And I get 29.38775511, whatever. So 29.39 would be how I round that meters. What is the total time in the air? Well, I can solve for time up here because I have enough information for it. However, if I solve for the time to this point, that's only half of my time. I have to double it. Okay, so I'm going to solve for it, but then I'm going to have to double it. So I'm going to go ahead and use this equation, VF equals VI plus A times T, because that's the easiest one to use. Okay, and so my VF is 0, my VI is 24 plus negative 9.8 times T. So I have negative 24 equals negative 9.8 times T. So divide 24 by 9.8. The negatives are going to cancel. And I get this, but that's only half of my time. That's the time to get up to the top because that's the point I was using. So I have to double it. My answer is 4.897, or yeah, 897, so that's going to round up to 4.90 seconds. Questions about that one? All right, a couple other things I want to mention, and I know we're running a little short on time. We've got 6 minutes, but before we stop talking about this stuff today, in addition to the quiz questions and the CFU yesterday, you guys also want to go ahead and take a look back at some of these past assignments because there are a couple questions on your test that weren't really covered super well in that. That thing only had 15 questions. Your test is a little longer. So if you want to make a note of these, you can. But look back at 202.1. Number 4, you need to know how to read a graph like this and answer questions about which way it's going. And then accelerating forward, accelerating backward, I'd rather use the words positive and negative instead, but you should be able to answer questions just like this. So go back and look at 202.1, number 4. Also, number 1. These are easy, but make sure you know how to do them. Okay, 202.1, number 1, and number 4. Okay, the other things that you need to look at, 202.3, different assignment. Okay, number 9. Okay, you need to be able to answer questions about things like this. Okay, this is an object thrown upward, and this is what that looks like when you plot it on a VT graph. This one's thrown downward. Okay, and that's actually what it's asking you to compare here. Dropped from rest, of course, would start at 0. Okay, so be able to interpret this as well, like this. What is the distance traveled by object in line B? Or if I asked you line A, you should be able to answer, you know, how far this has traveled. And of course, here's where it turns around. So here's where it's going up, how far it goes up. Here's when it falls back down. Be able to do that. Okay, that's number 9 on 202.3. Also number 7. And I told y'all this when we did it. We had a warm-up like this as well. You will have a question like this on your test. You can look back at my warm-up question that was like this, or you can look back at 202.3, number 7, but make sure you know how to do this. Okay, additionally, and a lot of these things are in the unit summary. Open up your unit summary and use it for practice. You'll have a test on Monday, but there's a lot of graphs in here. There's a lot of stuff in here. You need to be able to do all the graph stuff, and I know some of you had trouble with that card sort, so do the practice in here. Make sure that you can match graphs. Okay, the kinematic equations we've had a lot of practice on, but here's those graphs again with the free fall stuff. Make sure you look at it. Okay, if you have questions, please make sure that you come and ask me. I don't know if anybody's staying today after school for tutorials since it's a Friday, but we can check. Or Monday morning if you have last minute questions. But do the unit summary. It is bonus points. It is practice. It is a daily grade redo as well.